If we take a snapshot of the cost buildup of products through our factory and look at where costs reside, we have work in process in our wafer fab. We have material in transit constantly from wafer fabs in the U.S. or Japan to assembly test sites in the Far East, whether it's in the Philippines or Malaysia or Taiwan. We have inventory in those sites, and we have finished goods in our product distribution centers.
In many manufacturing settings, all units are not necessarily started and completed in the same accounting period. To account for these partially finished goods, it is necessary to compute equivalent units. There are two methods for computing equivalent units: weighted average and first in, first out, or FIFO. We will use the weighted average method. Goods completed and transferred out include beginning work in process and goods started and completed during the period. These are 100% equivalent units. Equivalent units are also calculated for ending work in process based on their percentage of completion. The basic idea of an equivalent unit is simple. One unit completely produced is equal to 2 units half completed. However, in practice, the calculations can get somewhat more complex. One complicating factor is that materials, labor, and overhead are not necessarily added to the product at the same rate. Therefore, equivalent units must be calculated individually for each of these categories. This is simplified somewhat if overhead is applied using direct labor as an allocation base, in which case the equivalent units for direct labor and overhead will be the same. In process costing, labor and overhead are often linked together as a single element called conversion cost. To compute equivalent units for direct materials, the number of units in process is multiplied by the percent of direct materials added during the period. In many manufacturing settings, 100% of the direct materials are added at the beginning of the process. Therefore, the ending goods in process are considered 100% complete with respect to direct materials. This is added to the number of units completed and transferred out of the department to get total equivalent units for direct materials. The same process is followed to calculate equivalent units for conversion costs. The number of units is multiplied by the percentage of completion. The beginning goods in process and the goods started and completed are transferred out at 100% completion. Notice that the ending goods in process is less than 100% complete. All the equivalent units are added up for the department total. So for each cost category, the units completed and transferred out of the department are added to the equivalent units still in process to arrive at the total equivalent units of production for the period. Equivalent units become the basis for calculating unit costs. The costs assigned to each category for the period are divided by the number of equivalent units to arrive at a cost per equivalent unit for direct materials and conversion costs, respectively. These are then added together to determine a total cost per equivalent unit for the department. Calculating equivalent units is widely practiced in a variety of industries.
One way we look at cost is on an equivalent complexity basis, because we have such a range of complexity that trying to manage the cost across a product line that has a 3x range of cost from simplest wafers to most complex wafers becomes a real challenge. So we may pick what we would look at as an average complexity wafer and then translate the least complexity wafers and the most complex wafers by some ratio into those equivalent units of average complexity wafers in order to understand both the capacity of our factories, in order to manage the cost of the factories and look at profit margins across a particular product line. And that gives us just one more means of being able to manage cost, be able to understand cost, and manage the diversity of products and processes.
For some operations, however, calculating equivalent units may be a waste of time.
In-process inventory is not one of those things that we look at here, because in-process in our facility is grand total of about 15 minutes from the time a bottle is made until it's turned into a finished product. So we don't make an attempt to figure out what's at work in process at the end of the quarter. So we either have raw materials or we have finished product. All of those are inventoried every month, and we evaluate that. And at the end of each month, we'll go through, we add up our expenses, we look at the total number of cases produced, and that's what gives us our cost per case, which is the measure that we generally look at.
This is the message.
The departmental production report summarizes the information provided by the process cost accounting system and makes it available for managers to use in their evaluations and decision-making.
We look at costs in our factories on a monthly basis for measurement purposes, and so the cost that's incurred in a particular time period in a month is assigned to the product that flows through that process or the factory in that month. This would be a typical report where you have a product and you have the overhead items and the material items and the total unit cost. And this would be a typical report a factory manager would see for a particular product.
Although formats may vary, the production report is usually in 3 sections. In one common format, Section 1 lists the total physical units and equivalent units to account for. The physical units include beginning work and process, plus those started into production. Equivalent units include those transferred out and ending work in process. The EU for materials and conversion come from the EU schedules shown previously. Section 2 reports cost information for beginning work in process and costs added during the period for materials and conversion. The materials and conversion costs are then divided by their respective EUs from Section 1. The result is per unit material and conversion costs, which are added together to get total unit cost. Section 3 reconciles the costs charged to the department by allocating them to the department's output. Using the costs per equivalent unit shown in Section 2, it computes costs for units transferred out during the period and for partially finished units remaining in process at the end of the period. These figures are added to arrive at the total costs, which must equal the total costs accounted for in Section 2. A separate production report is created for each department. Note that the figure in Section 3, representing total costs transferred out of the department, flow to Section 2 of the production report for the next department as costs transferred in. In practice, the format and frequency of summary reports varies between companies and even between departments. Different reports support different kinds of decision-making.
We have a variety of reports we use in managing our factories, managing our costs, and managing our product lines. A factory manager can get accurate cost information looking at the cost points, looking at the cost buildup of the various cost drivers, payroll and benefits, the materials cost in terms of chemicals, in terms of substrates, in terms of equipment depreciation that goes into each one. Our factory managers will have those costs on a regular monthly basis. They use that to go make cost reduction efforts to manage their cost. However, on a product basis, our product managers get a different cut of the data. They can look at quarter-by-quarter trend, what the cost of manufacturing those products are, and how much test costs went into a product, how much assembly costs went into a product, materials cost. So the decisions those managers make are of a different nature.
Departmental summary reports can also help managers to improve product quality yield and cost reductions.
One important aspect of understanding the cost of a product is to understand the cost buildup of the product as it flows through our factories. And cost of a product very early is just basically the raw materials and a low amount of labor content of a wafer as it comes into the factory, a wafer that may cost $40 for the raw substrate and is going through 1 or 2 mass steps. Again, the cost we've invested at that point is relatively low. After that wafer has been through the wafer fab process and been through 20 or more mass steps, we have upwards of $500 invested in that. If we drop and break a wafer or do a misprocessing step or whatever at that point, we've lost a bunch of money. Further on, we ship the wafer from our Dallas manufacturing fab to our assembly test site in Taiwan or in Malaysia. By the time we get done, we've invested probably 2x the amount of cost we had when it left the wafer fab. So how many more wafers is that over and above what you ordered? And if at that point we find that we, because of an error in our test program or because of a customer correlation issue or some other problem, we have to end up scrapping product at that point, becomes very expensive. So that directs our focus on where to put yield improvement efforts, where to put cost reduction efforts, engineering efforts, and in particular, it focuses our effort on how do we deal with customers on making sure that at the end of the day we're meeting their expectations and their requirements.
Putting together an analysis that will show what would happen if we went to 2,500.
Detailed product cost systems are complex and expensive. Why not simply report total costs and total output for a period?
Thinking about why we have a product cost system, one way to look at it is to think of one extreme where we would have a factory where we only would measure all the costs that go into that factory, add them all up, and measure the revenue we get from the products coming out of that factory, and certainly we could measure a profit margin from that. But in terms of getting the results we want to achieve, of growing revenue, of running good profit margins, the information we have to manage that would be almost nil. So to look at how do we manage the situation in an environment where we have a multitude of different products, where we have a multitude of different cost drivers in terms of payroll and benefits cost, materials cost, facility and infrastructure cost, R&D cost, to the extent that we can attribute the cost to the products that we're manufacturing. It allows us to go in and make decisions that we have to make on a day-to-day basis of which products do we need to cost reduce, which products do we need to obsolete, which products do we need to push in the marketplace. And to make those decisions, we really have to have cost and or product basis. And to make better decisions, we need more accurate information on a product-by-product basis.
These that have the check.
The departmental production report addresses 4 basic questions. How many units were worked on in the department? How many equivalent units were produced with respect to materials, labor, and overhead? What were the material, labor, and overhead costs per equivalent unit? And finally, where are the units and their respective costs now? The departmental production report is the key document in process cost accounting and is one way in which it differs from job order cost accounting. It reflects the difference in the way costs are accumulated by department or process rather than by the individual job order.